For as long as humans have looked up at the night sky, we've seen the same thing: stars. But one place in the cosmos is so strange that it has none. It's a galaxy without stars, a black hole surrounded by nothing but darkness. And astronomers just found another one. In fact, it's actually really hard to believe this galaxy exists because it shouldn't. Like all galaxies, this one has dark matter, which should eventually turn into stars. So to get there, astronomers use a statistical method called a stacking algorithm, which throws a bunch of images into a blender and creates an average image. Well, except for one small detail, because it turns out the average galaxy should have a supermassive black hole in the middle. These galaxies don't have a lot going on, but they do have a bright spot in the middle. That's light that's been squeezed and heated to extreme temperatures by the black hole's gravity. The light was coming from a place in space so far away that it took 7 billion years to reach Earth. Otherwise, the light would have shot out immediately. But it also didn't have much stuff in it. If it did, the light would have been delayed for weeks or months as it bounced around. The team thinks this black hole is probably around 100,000 times the mass of the Sun, but they couldn't detect any stars nearby. Maybe they started out as a lot smaller black holes that eventually merged to make something much bigger. Or maybe the black hole is surrounded by a gigantic cloud of gas that's fueling its growth. After all, just because they found two doesn't mean they found all of them. And the more of these galaxies they find, the more they'll learn about what makes galaxies in general, and our own Milky Way, tick. They just have to keep scanning the skies and hoping that this time they see something new. But since these galaxies are so far away, all astronomers can do is speculate. They need more data to figure out what's going on. Either the galaxy had barely started forming stars yet, or something was preventing them from forming. So if it finds anything interesting, it will almost certainly report it. The James Webb will help astronomers learn whether these galaxies actually have any stars, whether the black holes have any gas around them, and whether they might have formed in a different way than normal galaxies. Maybe they're not just empty, maybe they're missing something else. Maybe dark matter doesn't collapse into stars the way we think it does. All of these questions can be answered with a few more observations. And while the signal came from a tiny patch of sky, the team could still measure how the light varied over time. And in 2020, they announced that they'd found another candidate, one that was slightly larger than the first. So, to all of our patrons, thank you for what you do to make this happen. And if you're not a patron, but you want to learn more about what that means, you can go to our support page. It was a black hole around 150,000 times the mass of the Sun, with basically nothing else around it. Both of these candidates are very far away, so they appear to be pretty early galaxies from when the universe was very young. But they're also both extremely massive black holes. That's important because it tells them how long the light was delayed as it bounced off stuff inside the galaxy. And based on the amount of delay, astronomers figured out that this galaxy had a medium amount of stuff surrounding the black hole. Not too much, not too little, just enough to make the light last a few days, as it made its way out of the galaxy. The light is emitted all over the electromagnetic spectrum, but it peaks in the X-ray range. And that gives us an important clue about what's happening. Every galaxy we know of has one of those. But black holes don't emit any light themselves, so they're invisible. They're only visible indirectly through their effects on other things. And for most of cosmic history, that's been true for the average galaxy too. And while they do consume a lot of stuff during the early stages of galaxy formation, they can't grow forever that way. Eventually, they run out of stuff to eat, at least stuff that's close enough to actually fall into the black hole. After that, their growth slows down and they start consuming stuff that's farther away. But even that process takes billions of years. Astronomers couldn't see its black hole. They could only watch the stars go around it. Essentially, the algorithm lines up a bunch of photos of galaxies and then calculates the average brightness at every single point across all those images. Then you get an average galaxy. Turns out that when astronomers made one of these composite images, they noticed that the average galaxy had a few features that the grand design spirals didn't when it hit something. That thing can re-emit the light in a different direction. And depending on the size of the object, that light can be re-emitted over and over again hundreds of times before it escapes the galaxy entirely. That process is called photon scattering. And it makes the light last a lot longer than it would have if it just shot out of the galaxy after one bounce. If astronomers can detect this extended emission, it can tell them a lot about what's going on inside the galaxy. Things like a central bulge of stars, older stars orbiting in the middle of the galaxy, and a huge halo of stars surrounding the entire thing. There are billions of other systems out there just like it. The reason we think that's the case is that it seems pretty average. We can observe lots of other systems that are much larger or much smaller, but this one seems like it falls right in the middle. And since we only have one of them to compare everything else to, we assume it's average. But for some reason, it just isn't. So here's the story of this galaxy with no stars and how astronomers are finding more of them. In astronomy, a galaxy is defined as a collection of stars held together by gravity, along with any planets, gas, dust, and dark matter that might be floating around. The word galaxy itself even comes from the Greek word galaxios, which literally means Milky Way. But the Milky Way is just one galaxy among many, and it's not even the best example. That title goes to something called a grand design spiral galaxy. Grand design spirals are pretty easy to identify because they have a lot of the stuff we associate with galaxies. A big flat pancake of stars with arms extending out from the center like a pinwheel. They also have a prominent bar-shaped structure in the middle and two smaller dense spheres of stars on either side of the bar. This particular shape seems to be pretty common in the universe too. Out of the thousands of galaxies we've observed, maybe 10% are grand design spirals, including our own Milky Way. First, let's talk about our solar system. You may have heard it's not actually a very special place. So if our solar system is kind of average, then the next step is to figure out what the average galaxy looks like. And while they do look like the archetypal galaxy, they're still not perfect examples of an average galaxy. The problem is that none of the galaxies astronomers have studied exactly matches this average. But now we have telescopes that can detect what black holes are doing, which means we can finally find galaxies that only have the bare minimum of stuff, just a black hole surrounded by darkness. See, light doesn't just move in a straight line. That's why they were so excited when NASA's Chandra X-ray observatory detected an ultra-luminous X-ray source in a previously uncatalogued black hole. It took a few days for the light to escape, meaning that the galaxy wasn't completely empty. This discovery prompted astronomers to start scouring old data looking for more galaxies like this one. And according to our understanding of physics, that shouldn't be possible. Black holes grow by consuming matter. So astronomers have a few ideas about how these massive black holes got so big so quickly. Luckily, scientists are already working on it. The James Webb Space Telescope is powerful enough to study the details of these galaxies without even trying. And in the meantime, astronomers can keep looking for more galaxies without stars. Thank you for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons.